Hi, everyone. We hope you can hear me. I'm a bit cold, you know. All right, cool. So let's get started. My name is Kennedy Torkura. I am one of the founders of a company called Mitigant. It's a cloud security company based in Germany. And so this afternoon, I'm going to be talking about optimizing cloud detection and response with security chaos engineering. So just to get used to the audience, is there anybody who practices chaos engineering? Show by your hands. Chaos engineering or security chaos engineering? You just test in production. Oh, yeah. That's kind of it. That's kind of it. How about detection engineering or threat detection? Anyone does that? Oh, yeah, cool. Nice. So hopefully we're going to have some nice questions afterwards. Right, so, just to mention that part of the things, part of the discoveries, research around security chaos engineering were things I did during my doctorate at the Oslo Institute. So from there, we founded the company, and we are kind of going through different phases of trying to talk to different customers and looking at different use cases. And today, I'm basically going to be talking about one of the use cases, which is how we can apply these concepts to threat detection in the cloud, specifically. Right, so we're going to be looking at security chaos engineering, what it is, maybe some differences it has with chaos engineering, and then cloud detection and response. Then we look at the limitations of cloud detection and response, then how we can overcome some of these using security chaos engineering, and then hopefully I give you a short demo. All right, so who hasn't heard about Netflix? All right, hopefully. All right, so we all have heard about Netflix, and I believe a lot of us also heard about chaos engineering. For those that have not heard about it, about a decade ago when Netflix moved to the cloud, they realized that the cloud wasn't what it is today. So there were a lot of problems. Virtual machines would just go offline without warning them, and it was a huge mess. And their way to fix that mess was to begin to use the tool they called Chaos Monkey, which was the tool that went around shutting down virtual machines. And the idea was to force engineers to build applications in a way that if a machine goes offline, it doesn't impact the users who are watching maybe the next blockbuster movie. And so this was very successful to the extent that even when AWS had problems with the regions, failed, Netflix was still up and running. So it was quite successful. So essentially, they were able to use this idea to introduce resilience. They were able to make enhance availability, performance, and also reliability. So when we come to security chaos engineering, we started looking at some people started looking at how you can kind of solve the problems that we have in cybersecurity using this idea. And this was kind of interesting because when you begin to look at security, we have, on the one hand, availability as one of the attributes for non-security and also for security. And of course, you have integrity, you have also confidentiality. But the core of this idea, the huge motivation was how can we actually practice cyber resilience? Like how can we actually be resilient against attacks? And I actually, by practicing security chaos engineering, you're able to achieve this, and we'll be discussing more about this in the next slides. All right, so due to the fact that I discussed with a lot of people around these concepts, and I came up with this mind map, and the idea was to be able to explain in a very simple way and different ideas, or there's different aspects of security chaos engineering. And the QR code you see there is actually a Miro board. So if you want, you can scan it. Where it's interactive, you can actually see all of the things we're going to be talking about on this mind map. So the first thing is we already discussed what security chaos engineering is. So simply put it, it is the application of chaos engineering to cybersecurity. Of course, Aaron Reinhardt, which is he's one of the guys who actually started talking about this idea. He came up with this other definition, which says it's the identification of security control failures through proactive experimentation to build confidence in the system's ability to defend against malicious conditions. So kind of putting together the whole idea that you have security controls, you have problems in the cloud, and you want to be proactive. And you don't want to wait for the problems to be knocking at the door before you start scrambling to be able to fix it. So you want to be able to identify these problems well ahead of time, fix them, and then you actually prevent the problem from occurring. So that's kind of putting it in a very concise manner. So why do we think about this? So we already talked about some of these. We have blind spots. We have things that maybe things we don't think about, right? Things that maybe other tools might not be looking at. And interestingly, these are the things that attackers look at. You know, attackers have that creative way where they look at the things you're not looking at. And that's one of the reasons why we continue to see successful attacks. So with security chaos engineering, we are forced to begin to think out of the box. We are forced to begin to poke areas where other tools are not poking, which might be uncomfortable, but we are not looking at the output. We are looking at the outcome. Also, we want to move from just being secure to being resilient, and these are two different ideas. These are two different things. We want to be able to not just prevent attacks, but want to be able to survive from attacks, right, with security chaos engineering. And the last point here is maybe some of us have heard about the idea of security theater, which is the idea that we just make assumptions either based on maybe what the vendors tell us or how we feel, or how we have our experience in the past. And this is not always objective because, your experience, even if you have been in the industry for 15 years, attackers are changing. So the reasoning that, okay, this is how we have done it in the last 1 decade is not always sufficient. You have to actually test and get evidence and make your decisions based on this evidence. And that's kind of one of the objectives of security chaos engineering. Okay, so now who can use it? Of course. Here, every security domain can use security chaos engineering. So we're talking about whether you're in compliance, or you're in threat detection, or you are in incident response, and there are use cases across all these domains. But more importantly, even non-technical people can use it. So here I have an example of people who are in crisis communication. And these are the guys who kind of take care of when there's fire, when the whole world hears that, okay, this big company has been hacked. They're the ones who go out to kind of either spread a positive impression, or most times they spread the negative impression, right? So you see when we had issues with some companies, they keep on releasing different press releases. But anyway, it's a whole process. So they have to also practice how to be able to formulate the stories in a way that they give the correct impression to the audience. All right, so where? And this is one of the most interesting questions I get from people. Unfortunately, maybe because of the way Netflix sold chaos engineering as if they are like, let's say they are already experts. There is this thinking misconception that you have to practice straight in production. Whereas when you speak with people who have been in Netflix, you realize that first Netflix, they weren't even hiring entry engineers as at that time. I don't know for now. So every engineer in Netflix at then was kind of already battle tested. So these are the kinds of people who were running these systems. And actually, they were not just going to test in production. They started from other environments and gradually moved to production. So the same thing here too. You can start from your local environment, like how we do for most engineering projects, and then you test it. When you are confident enough, you can propagate to every other environment. The most important thing is because it is very challenging for you to have a one-to-one mapping between development and production or any other environment, it becomes challenging to transfer your learnings to production. So this is something you always have to like solve and say, well, if I was able to take care of this kind of security problem when I tested in QA, I can carry the same learning to production. It might be that you have different things that you have to like think about. But ultimately, or let's say, we always encourage people start from where you are more comfortable with, and from there you can propagate. All right, so here we have a high-level diagram that talks about how to practice security chaos engineering. So on the left, we have where you define your hypothesis, which basically is like what's your gut feeling, like what do you want to test? And this is very important because the idea is not to cause pain for people. People are already in pain. You want to take away the pain. So there has to be a very precise aim for why you want to do it. And one point which is not here somehow, I forgot, is before you even start coming up with a hypothesis, you need to understand, let's say, the state of what you're going to test. So a very simple example, you want to test whether you can identify, let's say, public S3 bucket. You have to know whether the bucket was public or private before you started, because at the end of the day, you want to reverse it to the good state. All right, so you define your hypothesis, then you inject the faults. This can be done at the code layer, the cloud layer, at the container layer, depends on what you want to test. And then on the other hand, you begin to observe the impact it has on your security tooling. And then in the end, you also look at how that impacts on integrity or availability or confidentiality. So we will see more clearer examples in the next slide. So this example is kind of, I won't say it's very simple, but here maybe we've heard about bucket ransomware. So this is something people have talked about a lot, and we know that today a lot of attackers are actually moving to the cloud. So here is a very simple example. So here, of course, you create a user called Bob, and next part here, that user, and bear in mind that you are the person kind of running it in your own environment, right? You are testing your own environment, so you're kind of doing these things to kind of see. It could be a teamwork, it could be like one-man show. But so when you get into the EKS cluster, you begin to enumerate. You're trying to find something that is interesting. You're trying to get all the names of the pods. And then at this point in time, the interesting thing is to know whether whatever you've placed to take care of security in this cluster works as it should. And this might be things like whether all of the noise you're making are being detected, or if the policies that should stop you from maybe calling the pods or asking them what kinds of permission they have, if all of those things are creating the correct kind of signals, and these are very important, let's say, interesting things you have to be on the lookout for. And of course, let's say somehow one of the pods is connected to S3 bucket. S3 bucket has PII or something that's interesting. Here, the attacker jumps from the cluster back into the cloud, gets access to this bucket. And here, if you have let's say, configured things like your CSPM, or you have things like guard duty, whatever, normally they should tell you something. They should give you some information. They should alert you, and all of this depends on how mature your security setup is, right? Then you get to the point where you receive a note, and the attacker is saying, hey, I already encrypted your bucket. You have to pay me X amount of dollars, otherwise I will do that. And you're beginning to think, well, do we just refuse to pay, or should we pay? Of course, no one wants to be in this situation, but this is what a lot of companies face. And it's not an easy decision, because if you already have made your backups and you're sure that the backups are not also owned by the attacker and the backups are not corrupted, and then you might say, yes, to hell with you. But if you haven't tested your backups, you don't know, maybe by the time you begin to try to restore them, they are like 1 year old or they are all corrupted. So this forces you to understand that these kinds of things like backups, incident response are not one of things. There are things you have to like practice. So at the end of the day, you get some learnings from here, and you can try to improve. All right. Any questions before we move into CDR? All right. All good. Okay, so now we start talking about cloud detection and response, and basically this is a definition by Wies, and basically it said it's a process of identifying and mitigating security threats or incidents in cloud environments through monitoring, analysis, and automated or manual actions. So the idea here is that detection and response technologies have evolved over time. And in the beginning, we had antiviruses. And later on, because of the threat landscape, EDRs came in, and they started looking at devices, trying to understand when you have X amount of employees and they're connecting to your network, you want to understand what's happening in their devices. And along the line, the attackers started going to the network devices, firewalls, and so forth. Again, vendors with analysts, they come up with these fancy terms that kind of describe the problem space. And then NDRs came. And then after that, XDRs came. And then, today, virtually every cybersecurity vendor tells you they have all of this, right? So XDRs promise they will take care of everything, including the cloud. But it turns out that, okay, when you begin to have multi-cloud architectures, and the XDRs begin to struggle with having to gather all the logs, how to analyze them, how to depend on a cloud service provider, and people see all these problems and said, oh, we think we need another category or another tool that actually just takes care of this problem. And that's kind of what people call CDRs today. So basically, CDRs want to look at the volatile nature of the cloud. They want to take care of all the, all the quick events that are happening in the cloud. We also have the problem of lack of sufficient skills. So, okay, maybe those of us who hire today, if you want to hire a cloud engineer, a cloud security engineer, it's very challenging. So in the end, you want to look for a tool that you can use that actually does this job to some extent. Right, so that also goes to cloud-specific tooling and technologies where you have to depend on cloud service providers for a lot of these kind of capabilities. And we have all this and I think one of the major ones here is the alert fatigue. So I think people who are into incident response, they're very much aware of these. And we will look at some examples of what the challenges that we have with alert fatigue. So, of course, they are not they're not silver bullet. The CDRs, they're just about 1 or 2 years old. They still have a long way to go, but it's always interesting to look at the problems they have so that there can be some kind of solutions. So the first problem is that of context. Of course, you can't buy context. If any vendor told you, hey, we would take care of your context problem, you have to really, really look at it with a pinch of salt, because context is your problem. It is you who understands what you're trying to defend. You're the one who understands the kind of employees you have, what you're connecting to, and you have to basically create your context yourself and kind of add it to your security system. The other one is alert fatigue. We already talked about it. If you deploy a threat detection tool today, it will just drop a lot of alerts for you. More than half of those will be useless, and meanwhile you will task a lot of people, security analysts, and so forth, to try to figure out what should be dropped and what should not be dropped. In the midst of this, there is always a mistake of actually dropping important things because somehow you were not able to triage them properly. All right, and of course we know that the landscape is moving very fast. Here you can see this is the MITRE attack techniques for AWS, and it's a lot of techniques we see here. And what I can tell you is they're not even complete, because MITRE faces the challenge of quickly going through the process of understanding the kind of techniques that attackers are using, creating it, testing it, and adding it here. And there are some initiatives that are coming up where the cloud service providers can be involved so that they can also, there's this very tight dependence on cloud service providers when it comes to cloud security. So, of course, the CDRs here, they kind of, they're challenged, and in the end, it becomes our responsibilities as the people who are, who are defending our organizations to kind of solve some of these problems. So essentially, what is a cloud tech? There are two aspects of CDRs. There's a threat detection and there's a threat response. So the threat detection here, you will see here, I'm looking at Datadog. I'm not related to them. Anyone works in Datadog? Okay. Just using them as an example. So here, most of them, what they would do is they will tell you to configure CloudTrail, to drop CloudTrail in a bucket, and then they will pull all that stuff from that bucket. That's the most common configuration. And most of them also, they're using Sigma rules. So Sigma rules are just some kind of way where you can analyze different kinds of log formats and figure out when bad things are happening. So what you see here is, and if you look at line 20, 21, 22, they are basically looking at CloudTrail event names. So stop logging, update trail, delete trail, and they want to be able to detect when these events are in any CloudTrail log so that they can do something about it, like send an alert. So this is the most common approach. Most of them use most of the big names you hear about. Then when it comes to threat response, similarly, it's like, okay, you find a signal comes, and what do you do about it, right? So here you have an example from AWS SSM, actually a document. So AWS they have different projects to help people, and here this document actually helps you to enable a CloudTrail trail that was disabled. So you can actually write Lambda functions or something like that to trigger this thing automatically, or you can do it manually. So this is kind of one way. Of course, the vendors might also have ways where they can do something. Either you deploy some kind of Lambda functions or some other techniques to respond. And here is also response could be like one-off, but actually most of the time you don't just restart a CloudTrail. You want to investigate to know what shut it down. Why was it shut down? There's a whole lot of things that you have to do, and here is kind of the process by AWS again, where they kind of give some best practices on what you should do in this case if you have a ransomware attack. Right, so let's look at an example just to kind of look at the problems that I've been talking about. And this example is about the Androx malware. So this malware was detected somewhere, I think last year by, if I'm not mistaken, by Lacework threat researchers. So it basically looks for an AWS credential file in the application, Laravel applications, and then it basically grabs the credentials from there, then tries to try them out against an AWS account. If it finds it to be successful, then it creates a user in the step 2. Then it attaches a privileged policy to this user, so to elevate its privileges, and the next thing, it creates a login profile, which allows the attacker to be able to log in to to that victim account through the web console, maybe just so it's easy for them to do what they want to do. Then it deletes that profile, the account it used initially, most likely because you can't revoke it, or you can't even see easily see the signals of the activities. And then from there's a lot of things you could do. Maybe there's a use case where they are kind of using SNS, so they want a very cheap way where they can spam other people without paying the bills for spamming. So this is kind of not very bad because they're not actively stealing anything. But the problem here is this is an ecosystem, so they might compromise a system, and then they will sell this compromise to other attackers, so it might go that bad. So what we did here is kind of to understand the implications for users. So we have built our security chaos engineering tool at Mitigant, and so it has the ability to basically emulate these kinds of attacks, or to some extent. So here what you see is it with the first step, or I think this should be the second step, where it creates the user. It attaches a policy that gives the user access to S3 entirely. And then here it's also creating the login profile. And then we said, okay, how does this look on Datadog? And one thing we realized here is like when you create a login profile on Datadog, obviously it's detected, but it has a low severity. So every detection has a severity, just so that to give you some context to it. Which is a problem, because here they're not able to understand that here it's actually this malware that is actually doing these automated actions which might lead to something. So a security analyst will dismiss this finding. And this is also in the Datadog, they have a tool investigator that allows you, basically kind of brings together different, let's say, different findings and tries to show you a map. And here you see on AWS IAM, there are like 12 event types, from creating the access key to deleting it to doing a lot of things. And so the most important thing to learn from here is to see there is a gap where, as we saw before, you as a defender have to jump in to understand what's happening. And the only way you understand is by actually emulating these attacks. There is no magic here. You just have to do it. Otherwise, you might be dismissing a lot of these kinds of findings as unimportant. All right, so let's go and see a bigger picture. Here it's just like a flow chart, which I think it should be big enough, right? All right, so this flow chart kind of starts from where you emulate attacks, and you use MITRE attack as the basis for what you should emulate. And then you begin to check your detection rules, whether they're firing or if they're firing incorrectly. That gives you the chance to kind of refine them and make some changes. So here, this flow chart is a little bit generic. So it might be that you are directly a vendor, so maybe you work at Datadog or Elastic, or you're using their product, or you are using some other things. So it's kind of generic here. But at the end of the day, you want to find a way where you're optimizing the rules, and then it doesn't end there. So you see these continuous improvement loops going back to the beginning, because the threat landscape keeps on changing. And so unfortunately, it's not, it's kind of like the way antiviruses have been built over the years, right? You don't just buy it and install it and you go home. The vendors keep on updating the antivirus. They keep on communicating, they keep on getting information, they keep on updating the signatures, kind of like that. So I think this is a situation where I found ourselves, especially in the cloud, and this is kind of one way to stay ahead of attacks. All right, so we're gonna look at a very quick demo. Unfortunately, I kind of didn't share my screen very well, so I have to do it this way. By the way, this is not a sales pitch, so really sorry for some people who don't like people selling. It's just to give like a real life example of what happens. So here I would just go straight to what like a use case. So basically we have built these attacks, and these attacks are all built in line with the MITRE attack. So if we look at one of them, here is to degrade password policy. So what this attack does is it connects to the AWS account, and then it basically goes to the IAM service, and there is the idea, you can actually configure your policies, set all of the, whether you want to use alphanumeric, the password length, and all of those policies, and it can just degrade it that, okay, anybody can use character lengths of 6, nothing more, right? And this degradation can just happen. It means that you as the administrator, you don't know that something has happened. It doesn't look very malicious from looking at it from the surface, but that means that actually your employees or people who are using it can just create A, B, C, D, E, F kind of password, and it will go. So this is kind of for you to even know whether you have any system in check that will trigger an alarm if this occurs. Of course, there are other more complicated kinds of attacks and that you can run. And we also have, apart from these attack actions, there are also attack scenarios. So the idea of the scenarios is to kind of put these things together so you can have, like Lego, you have create IAM user, you create IAM backdoor, public S3 bucket, so kind of gives you an impression of what actually happens. So because attackers don't just, most of the time they don't do one thing, they do many things. So, and this allows you to be able to have an understanding of the chain of events that could occur, and then you can have the possibility to kind of like configure your tools properly. So let's just look for a very simple one here. Public Lambda, public S3, and this. So once you run it, and by the way, this is completely agentless. So it connects to the cloud. One huge, let's say, caveat for this kind of thing is that whatever is executing it needs privileges to your account. Now, it needs privileges because it can do this. Some people say, hey, it's difficult for privileges to be gotten. I said, well, it's difficult, but this is kind of what is happening these days. So a lot of attacks are coming because attackers get API keys either from GitHub, or they compromise, like the one we saw. Malware gets into a developer or head of DevOps laptop, checks and sees the keys and begins to use it. So here you have to like fill. So I'll just write test here, and then it tells you just briefly what's going to happen to avoid surprises. You will see a new bucket. It's going to be, a bucket will be made public, and VPC also will be Lambda will be taken out of the VPC, and then you start your attack, and it connects to the cloud. And it's quite fast because it's happening by APIs. And then you begin to see just a little bit of the steps that are executed during this process. And that's pretty much fast. And that's the report already there. And then you can basically see it. A couple of things that I want to mention that are important here is like, so the attack will be recovered afterwards. And meaning that it will be taken back. So for instance, in this public Lambda, the Lambda function is taken out of the VPC, and that state where it was before, the VPC name, where it was configured, will be kind of, it will be noted down, and then afterwards it will be reconfigured. And you also have attack remediation, which is like, what do you do about it? And this is very important. And also, we're gathering the evidence. Right now, it's still going to gather it because we're gathering it from CloudTrail and GuardDuty, which turns out not to be real time. So you have to wait for a few minutes before you can pull that out. And of course, I can basically just show you quickly. Let's see if some of the old ones. So this is an example of the evidence we're fetching, and this evidence is gotten from CloudTrail, and you can see the the URL of the link of the cloud trail, the event ID, and all of that kind of stuff, which will become very important for maybe the engineers to work with. All right, so I think just to wrap up now, so what we see is that security chaos engineering is the idea that we kind of take the same learnings that the companies or the people who use chaos engineering or who use it to transfer it to cybersecurity. And of course, you can use it in different ways. One of the major advantages is we want to move from, not just trying to prevent attackers, because you can't completely prevent all of them. Eventually, somehow they get in. And the idea here is we're not looking at those that we're not trying to stop them. We're trying to understand when they're in already, and how do we notice when they're already in our environment. How do we know whether our tools are functioning the way they should, and how do we know whether the remediation actually stops them? Of course, at the end of the day, there are many use cases, and this use case is the use case of CDRs. There's also use cases of incident response, which we didn't look at in this talk. And that's the end of my talk. And I think I will stop here. If you have any questions, thank you so much for listening to quite boring talk.